Alright, now we're working on the review for the first quadratic test. We are going to start by converting the following quadratic functions to vertex form. Up here we have a couple of the formulas we need. Probably the most important ones are the axis of symmetry and the C value. I think we should probably add this one on here too. C is equal to 1 over 4a. And then also we have standard form and vertex form listed for us, so we can go back and look at it. It says convert the following quadratic function from standard to vertex form. Well, to go standard to vertex form, here's vertex. We're going to need the a, the h, and the k. So I'm going to go ahead and just list out a, h, and k. To get a, h, and k, we have to figure them out from this equation. The easiest one is going to be a. A is simply the first coefficient. If there's nothing there, it would have been a 1. But the first thing we come across there is a 4. That's a coefficient on the x squared term. So a is done. A third of our what we have to find is done. Next we have to find h. To find h, remember h in when we're looking at our vertex is h, k. H is our x value, and k is our y value. So we have an x value up here in our axis of symmetry. That's the x value we're going to look for. So what we're going to do is for h, we're going to say h is equal to negative b over 2a. And that's this equation here for the axis of symmetry. Negative b, 2a. So let's list out a, b, and c. My a is 4. We already mentioned that one. B is the second coefficient, and C is the constant at the end. So negative B, B is my 4, so I'm going to put a 4 in there, and A is my 4 as well. So I have negative 4 over 8, and that equals negative 1/2. So my H is negative 1/2. For my k, I'm going to take that value that I got in h, that x value, remember it's an x value, and I'm going to plug it in for all of these x's across here. So for k, I have that equal to 4x squared plus 4x plus 5. And each of these I'm going to put the negative 1/2, negative 1/2 in like that. To keep things simple, let's just put these in the calculators. The first one right here, you could have just plugged in alpha y equals negative parentheses 4, all that, it would have worked and gotten us our negative 1/2. This one, we're going to put a little bit more in, so 4 parentheses alpha y equals negative 1 over 2, and we are going to square all that, plus 4, and we're multiplying by negative 1/2. If you wanted to, you could have put that in as a decimal, negative 0.5. That would work just as well in this case. I hit enter, and I get 4. So all this is equal to 4. K is equal to 4 right here. There's my values. So I look back up to vertex form. F of x is equal to a. What is my a value? My a value is 4. And I'm going to have parentheses x minus h. H is negative 1/2. So what I'm going to do, since it's in the parentheses, I change the sign. Negative is going to go to positive 1/2 squared plus k. K is 4. That's what I'm looking for right there. Next one, describe the meaning of the directrix. Be specific. Draw an illustration if necessary. Ooh, interesting. So let's look at this. I'm going to draw a parabola. Here's my parabola. My directrix is always outside of the parabola and opposite of the focus. So what the directrix is, well, let's just first talk about where it is. This distance from the directrix to the vertex is the same distance as the the vertex to directrix. Focus to the vertex. So this is my directrix, this is my vertex, and this is my focus. These are the same distances. That distance is also always the same no matter where you are. The way we get this curve is saying those distances are the same. Or we can look at this point over here. This point is the same distance here. So this distance is always the same. The distance from the focus to the parabola and the parabola to the directrix line is always the same. And the directrix line equation is always written as y equals whatever this horizontal value is. Alright, last one, second to last one on this page, we're going to do this whole graph area on this. We have axis of symmetry is -3, so let's go ahead and label my axis of symmetry. My axis of symmetry is x equals -3. I'm going to graph that on the page first. So -3 right here. That's my axis of symmetry. My vertex is going to be somewhere on this line. It's going to be somewhere on this line. Okay, I have that right here, by the way. My range, -5 to infinity. My range, -5 to infinity. So my lowest point is it's going to go to infinity, which is forever and ever up. My lowest point is at -5. So right there, that's my vertex. My vertex is going to be -3. That is my left and right number. That's my axis of symmetry where it's at. And then I'm going to go all the way down to -5. That is my vertex. Alright, and then the length from the focus to the directrix line is 4 units. Focus to directrix line. That distance we talked about, focus to the directrix line, halfway in between is my vertex. Halfway in between is my vertex. So that's 4 units. If that's 4 units, 2 of those are going to be above, and that's going to be my focus, and 2 down is where my directrix line is going to be. So let's check that out right now. So my C value, my distance here, 1, 2, 1, 2. That's going to be a C value of 2. Usually it's written if my C is positive, my focus is up. If my C is negative, my focus will be down. So it kind of tells you what direction it opens. My directrix line, let's look and see what this is. It goes all the way down to y equals -7. Y equals -7. My focus, let's check out my focus point. It's going to have the same x value from the axis of symmetry in my vertex, but it's going to be up here, kind of look across, to -3. So it's actually -3, -3. Domain, we can actually go ahead and do. What's the domain in all my equations? They're always, when it's just a function, a quadratic function, it's always going to be -infinity to +infinity. Last thing we have to work on here is getting the equation done. My equation, well, first we can just go ahead and start listing out where my vertex is. We're going to put it in vertex form. And as we talked about up here on top, we have my vertex. My vertex number is HK. H and K go in here. So we're going to do everything but this A, and we're just going to fill in H and K in this part of the vertex form. So we have X, my x value is negative 3, so I'm actually going to put a positive 3 because everything in parentheses is going to be opposite. And my k value is going to be negative 5. That stays the same. The only thing we need now is a. At the very top we got a for formula, so I'm going to write that down here. A is equal to 1 over 4c. I like to put c in parentheses. It just kind of reminds us what we're doing. 1 over 4 and c is 2. So that gets us 1 over 8. My a value is 1/8. So I'm going to take that a value and put that right here. Once I have that, my equation is completely done. 1/8 x plus 3 squared minus 5. And let's finish out this page. On the bottom, which equation best represents the function shown on the graph? Well, we have an equation that we got. We just need to put it in standard form. Our equation is in vertex form. We got to transfer it to standard form. To do that, we have to multiply it. I'm going to carve out some area here for us to work on it. I'm going to rewrite it. 1/8 x plus 3 squared minus 5. First thing I have to do is multiply those parentheses. Everything around the parentheses, we're going to cut off. Okay, so I was wrong. We're not converting this to standard form like we did above. We actually need to just look at this graph here. So let's look at this graph and get a couple of the attributes, see what's happening. First thing we need to know, it's actually shifting. It opens down. It opens down, which means this one and this one are out. Those are positive. Then I look over here at these. One of the big differences here is the y-intercept. This has a y-intercept of negative 4. This has a y-intercept of positive 4. My y-intercept is here a negative number, so it's going to have to be a.